This is the video for accelerated geometry on section 17-1 and 17-2. 17-1 is on right triangle trig, which is going to be a lot of review of what we did last year. The essential question is, how do you determine the side lengths of a right triangle? Vocabulary in this lesson is cosecant, cosine, cotangent, secant, sine, tangent, and trigonometric functions. To begin reviewing the trig functions that you learned last year, the sine of angle theta is just opposite over hypotenuse. The cosine of angle theta is adjacent over hypotenuse, and the tangent of angle theta is opposite over adjacent. The new material is the reciprocal of those functions. So cosecant of theta is just the reciprocal of sine. So instead of doing opposite over hypotenuse, it's now hypotenuse over opposite. Secant of angle theta is the reciprocal of cosine, so then that's just going to be hypotenuse over adjacent. And cotangent of angle theta is the reciprocal of tangent, so it's going to be adjacent over hypotenuse. So example 1 says to find the value for all 6 trig functions for theta. So the first thing we need to do is find this missing side length. So this is a right triangle, and as you learned last year, you can use Pythagorean theorem where a squared plus b squared equals c squared, where a and b are your legs and c is your hypotenuse. So we would have 70 squared plus 24 squared equals c squared. So this is going to be, 4,900 plus 576, which gives me 5476. Take the square root of that, so the square root of that number is c, which comes out to be 74. So I'm just going to label that on this side of the triangle. So then it says all 6, so I need to find the sine of theta, the cosine of theta, the tangent of theta. Then I need to find the cosecant, the secant, and the cotangent. So sine theta would be, if I'm at this angle, across from it, it's going to be the opposite. The one next to it's the adjacent, and the hypotenuse is always across from the right angle. So sine is opposite over hypotenuse, so that's going to be 70 over 74, and you always need to reduce your answer, so this reduces down to 35 over 37. Cosine is adjacent, which is 24, over hypotenuse, which reduces to 12 out of 37. And tangent is opposite over adjacent, which reduces to 35 over 12. Cosecant is just the reciprocal of sine, so that's going to be 74 over 70, which is 37 over 35. Secant is the reciprocal of cosine, so that's 74 over 24, which simplifies to 37 over 12. And cotangent would be the reciprocal of tangent, which would be 24 over 70, which equals 12 out of 35. And that is the lesson for 17-1. So next we're going to look at 17-2. 17-2 is on angles of rotation, and our essential question for this section is, how can you understand angles of more than 90 degrees or less than 0 degrees? So some vocabulary in this section is going to be angle of rotation, coterminal angle, initial side, reference angle, standard position, and terminal side. So our first word is, an angle is in standard position when its vertex is at the origin and one ray is on the positive x-axis. So what that is saying is that one has to be on the positive side of the x-axis. The other one can go in anywhere, so let's just put it over here. But as long as one ray is on the positive x-axis and the vertex is at the origin, then it's in standard position. The initial side of an angle is the ray on the x-axis. So in this example, this would be your initial side. The other ray is called the terminal side. So this side over here would be my terminal. Now we have positive rotations and we have negative rotations. So if the initial side is on the positive x-axis and we rotate counterclockwise, which is going up from your initial side, then we're going to have positive rotations. When we have our initial side and we rotate clockwise, which means you're going to go down, then we have negative rotations. And an angle of rotation is formed by rotating the terminal side and keeping the initial side in place. And as I just said, a positive angle of rotation is when you go clockwise, and a negative angle of rotation is when you go, positive is when you go counterclockwise, and negative is when you go clockwise. The terminal side can be rotated for more than 360 degrees. So if we look at this right here, yes, we could say that if we just did this piece right here, we could say that that's 30 degrees. But if you notice, it went all the way around once. So a full rotation is 360, and then I continued a little more and got 390. So if you see something like this, pay attention to how many times it goes around. For every time that it loops around, it's 360 degrees. So as a reminder, a 360 rotation is a complete rotation, and a 180 degree rotation is just half. So if you were to start on the x-axis and end immediately back on the x-axis, that's 180 degrees. So in these examples, it says to, let me move this out of the way. It says to draw an angle with the given measures in standard position. So we know that our initial side is going to be on the x-axis. And then we want to go 320 degrees, and it's positive, so that tells me I need to go counterclockwise. So as a reminder, this would be 90 degrees. This would be 180 degrees. This down here would be 270 degrees. And this is 0 degrees, 360 degrees, etc. So I'm going to go past 90, past 180, past 70, and then a little more than halfway to get to roughly about 320 degrees. And then you're going to draw an arrow indicating that that's the end of the rotation, and then label it 320 degrees. Now, does this have to exactly be in the right spot? No, but we are looking for the arrow on the end indicating that that's the end of it, and that it's definitely labeled that it's supposed to be 320. Number 2 is negative 110. So we're going to have our initial side on the x-axis, Negative means we're going to go down clockwise. So this would be negative 90, negative 180, negative 270, and this would be 0 and negative 360. So negative 110 is more than 90 and a little bit. And then draw your arrow indicating that that's the end, and then label it as negative 110 degrees. Now, what I want you to do is to pause the video and try number 3 and 4 for yourself. So on example 3, we're going to start the x-axis, 990. I know that that's definitely going to be a full rotation, so if I subtract 360, what does that leave you with? And so that's still more than 360, so I'm going to do it again. And that leaves me with 270. So I know I've gone 2 full rotations and then an additional 270. So I've gone 1, 2, that's 2 complete right there, and then back to 270 degrees. And that should be right there on that y-axis. I'm actually going to change that color so you can see it clearly. And then we're going to label that as 990 degrees. So for negative 300, you would start on the x-axis, but now we're going to go down. That would be 90, 180, 270, and a little more. Put my arrow and label it as negative 300 degrees. Coterminal angles are angles in standard position with the same terminal side. So, for example, if you think about the problem we just did with the 990 degrees, we went all the way around twice, and then landed back at the 270. So we could actually say that 990 and 270 are coterminal because they have the same terminal side. Now you could also say that negative 90, because that would be going this way, you could also say that negative 90 is also another coterminal angle for that same degree. Or if you only went around once, so you would have the 360 plus the 270, and that would be another coterminal angle. So coterminal angles are any degrees that have the same terminal side, whether you're going counterclockwise or whether you're going clockwise. Now, there are an infinite amount of coterminal angles, but one way you can find them is to add or subtract integer multiples of 360. So, for example, On number 5, we want to find a positive angle and a negative angle that are coterminal to each. So for 65 degrees, the easiest way to find your smallest positive and largest negative angle is just to add and subtract 360 degrees. So if we take the 65 and add 360, that's going to give us 425 degrees. And then if you take the 65 and subtract the 360, that will give me negative 295 degrees. So these would be two coterminal angles where one is positive and one is negative. So on number 6, we have negative 110 degrees. So I'm going to take the negative 110 and add 360 to get 250 degrees. And then I'm going to take the negative 110 and subtract 360, and I'm going to get negative 470 degrees. We have one more type of angle, and that is what we call the reference angle. So it says, for any angle in standard position, the reference angle is the positive acute angle formed by the terminal side of theta and the x-axis. So the key word here is that it has to be an acute angle. So if we look here, if this one is theta, this is not an acute angle, which means we would need to use this angle over here as our reference angle, because it also takes us back to the x-axis. That's the other key word, is that it's with the terminal side of theta and the x-axis. So let's look at this. If we find the measure of the reference angle for each of the given angles, so theta equals 135. So if I think of this in terms of 135 would be in the second quadrant right here, then I would have to find this angle here. Well, we know that the whole thing here is 180. So I can just say that theta's reference angle is 180 minus 135, which would equal 45 degrees. Now, before I go any further, let me give you a little word of advice here. If you're in the first quadrant here, if theta's in the first quadrant, so say your angle is right here, then your terminal side is going to make an acute angle with the x-axis. So over here, your reference angle is just theta. If you're in the second quadrant, like we were for 135 degrees, your terminal side, the acute angle formed with the terminal side and the x-axis, is going to be 180 minus theta. If you're down here, so say your angle goes down like this, then this would be theta, right? The whole thing would be theta. So then to go back to the x-axis, it's going to be this piece right here, which essentially is going to be your angle minus 180. And if you're in the fourth quadrant, theta is going to be this whole piece. So then you need to go back to the x-axis, so we're looking at this piece over here. So in the fourth quadrant, it's just going to be 360 minus theta. And so whether you understand the little drawings here, what really needs to be understood is that in the first quadrant, your reference angle is just going to be theta. In the second quadrant, your reference angle is going to be 180 minus theta. In the third quadrant, it's going to be theta minus 180. And in the fourth quadrant, it's going to be 360 minus theta. Now, all of this is if it is a positive angle. If it's a negative, you're first going to have to make it a positive. So with that, let's look at number 8, where we have negative 105 degrees. So a negative 105 would be, I'm going to erase this for a second. We're going negative 90 and then a little more. So negative 105 is over here. So this would be my theta equals negative 105. So in reality, that angle is really, if I find the other coterminal, is the same thing as 255 degrees as a positive angle. So it's in the second quadrant now, so I can say that my reference angle is just 255 minus 1/8, which leaves me with 75 degrees. Number 9, we have theta equals 325 degrees, so it's already a positive. And if I think about this, 325 degrees is going to be in the fourth quadrant. So then, if I remember my little rule, then it's just going to be 360 minus theta. So my angle, my reference angle for theta is going to equal 360 minus 325, which comes out to be 35 degrees. To determine the value of any trigonometric function for an angle theta in standard position, begin by selecting a point P with the coordinates x, y on the terminal side of the angle. So if you notice, all I've done here is we have our theta here, and this is our this is our terminal side, and we've labeled a point way up here. Well, in order to get to that point, you just go over x this way and up x this way. So if I want to know the sine, then that's just going to be, if we put theta here now, and we're looking at just this right triangle, the sine of this theta is just going to be y over r. Cosine would be x over r. And tangent would be y over x. So then cosecant is just the reciprocal. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent. Now this will make more sense to us in just a second when we work an example. So example 10 says that point P at negative 6, 9 is a point on the terminal side of theta in standard position. Find the exact value of the 6 trig functions for theta. So what we're really looking at here is if I went negative 6 this way and then up 9, and that should be a right triangle. We'd have a right angle right here. Here's our point P, and this would be R, and this is now theta. So first thing we need to do is find R. So R squared equals 9 squared plus negative 6 squared. R squared equals 81 plus 36. So R squared equals 117. So R is the square root of 117. So then if I go back and label this, then my sine of theta is 9 over the square root of 117. But we cannot leave it like this. You have to rationalize the denominator. So we're going to multiply by the square root of 117 over the square root of 117. So that's just going to be 9 radical 117 over 117. The cosine of theta would equal negative 6 over the square root of 117. So again, we're going to rationalize. So that's going to be negative 6 times square root of 117 all over 117. And then tangent would be 9 divided by negative 6, and we're going to reduce that to negative 3/2. So then we need to find cosecant, which is just the reciprocal of sine, so that's going to be square root of 117 over 9. The secant is just the reciprocal of cosine, so that's going to be the square root of 117 over negative 6. Or if you wanted to write it as negative radical 117 over 6, that works too. And then the cotangent would be negative 6 over 9, which would give me negative 2/3. So what I want you to do is to pause the video and try number 11, and then come back and check your answer. So when you work number 11, you should find out that your r is 3 radical 5, that your sine of theta comes out to be 2 radical 5 over 3, cosine theta equals negative radical 5 over 5, tangent of theta is negative 2, cosecant is equal to radical 5 over 2, secant is negative radical 5, and cotangent is negative 1/2.